And now going to part B, we are going to solve part B using two methods. The first method will be the gradient function method. Gradient function method. Method 2 will be the concept of perpendicular lines. The concept of perpendicular lines. So we are going to start with method 1. Method 1. And we are solving part B. So part B says find the equation of the tangent to the circle x squared plus y squared minus 4x plus 2y equals to 3. And the point of tangency is given as 0 and negative 3. The point of tangency is the point on the circumference of the circle where the tangent touches the circle. So when we are using method 1, that is the method of the gradient function, it is not necessary for us to escape the circle. What is very important that we must always keep in our minds is that the point given here is a point of tangency. That is the point on the circle where the tangent meets the circle. So when we are using the method of gradient function, we treat the equation of the circle as an implicit function. We treat it as an implicit function. So what do we do here? We are going to differentiate the equation of the circle with respect to x. So I'm going to say d of the function dx, for which the function is on the left hand side we have x squared plus y squared minus 4x plus 2y equals to d dx of the function on the right hand side, which is 3. So we are going to differentiate this with respect to x. So if we differentiate x squared, what do we get? We get 2x. We have differentiated the function in x, so we say dx, but with respect to x, so dx plus, just because there is plus, if we differentiate y squared, we get 2y, but this is a function in y, so we shall say dy, but it was with respect to x, dy dx. And then negative 4x, if we differentiate negative 4x, we shall get negative 4. It is a function in x, so we shall say dx, but with respect to x, dx. Then you come to plus 2y. If you differentiate positive 2y, you shall get positive 2. But it is a function in y, so we say dy, but with respect to x, dy dx equals to, if we differentiate a constant 3, you get 0, equals to 0. And then when we simplify this, dx and dx are going to cancel the same here. So we shall have, therefore, we shall have 2x plus 2y dy dx minus 4 plus 2 dy dx equals to 0. Remember, when we are getting the gradient function, it simply means we want to find dy dx, which is the gradient, which is the function that gives us the gradient of the circle at any point on the circumference. So from here now we need to make dy dx the subject of the formula. So we collect the like terms. So dy dx, we shall group them together so that we shall have 2y dy dx plus 2 dy dx equals to, we are carrying 2x and negative 4 to the other side of the equation. So negative 4 becomes positive. Positive 2 becomes negative 2. Positive 2x becomes negative 2x. So let's see how we can make dy dx the subject. So let me factorize here. Let me factor out dy dx because it is common. So that I'll be left with 2y plus 2 dy dx equals to 4 minus 2x. Now I need to make dy dx the subject. So I'll say both sides by 2y plus 2. Therefore, we shall have dy dx equals to 4 minus 2x over 2y plus 2. This is the gradient function of the circle. This is the gradient function that we are looking for of the circle. Why is the gradient function important? The gradient function is important because it is the function that defines for us what the gradient of the circle would be at any point on the circumference. And now we know one point on the circumference. This is the point of tangency. So this is the gradient function of the circle. Now, what is the gradient of the circle at the point of tangency? 0, negative 3. So we say at the point of tangency, which is 0 and negative 3, we need to find the gradient of the circle. Therefore, the gradient of the circle at point 0, negative 3 will be, substitute, this is x, this is y. We shall have 4 minus 2 times x, which is 0, out of 2 times y, which is negative 3 plus 2. Then you place the calculator. So 4 minus 2 into 0. I'm getting 4 over 2 times negative 3 plus 2 over negative 4. This is not 4. Yes, it is 4 minus 2 times 0. I'm getting negative 4. So when we divide this, we shall have negative 1. So negative 1 is the gradient of the circle at the point of tangency. Okay? What do we know at the point of tangency? At the point of tangency, the gradient of the circle is the same as the gradient of the tangent. Therefore, gradient of the tangent is also negative 1. After getting the gradient of the tangent, now we need to find the equation of the tangent. Now we know the gradient of the tangent and we know one point through which the tangent passes. Therefore, now the equation of the tangent here, we have the gradient of the tangent. Let me call it n. We have n, which is the gradient of the tangent as negative 1. And then we have one point on the tangent. That is the point of tangency, which is 0 and negative 3. A tangent is a line. If you know the gradient of a line and one point on that line, then you can simply find the equation of that line. So the equation of a line is given by y equals to mx plus c. This is x, this is y, and we have m here. So we need to find c. So you substitute negative 3 equals to m is negative 1 times x is 0 plus c. Y is negative 3, m is negative 1, x is 0 plus c. So what is the value of c here? C here becomes negative 3. Remember, c is the y-intercept. So from here, after getting c, then you just come back and substitute for m and c only. Therefore, now the equation becomes y equals to m. M is negative 1, x plus c, which is negative 3. Negative 1x is the same as negative x. Therefore, y equals to negative x minus 3. And therefore, this is the equation of the tangent to this circle at the point of tangency 0, negative 3.